In this section, we're going to talk about simplifying variable expressions. In the last section, we would evaluate those expressions and come up with a number answer, but sometimes we want to keep them in terms of variables so that we can look for patterns and different things along of that nature. So before we get too far, just some other vocabulary terms that it's always good to define when you start, so you know what we're talking about as we use these words in the context of this discussion. One thing we'll talk about a lot is something called a term. A term is very simply this. It's a constant, a variable, or a product of a constant and one or more variables. Being raised to powers. So some examples of some terms, something like maybe 3x squared, or -4, or 1/3 x squared y to the 9th. Any of those would be examples, or even just plain old x. Any of those are examples of a term. Just a number multiplied with a variable, with powers, or any combination of those things. The word coefficient is just the constant part of a term. This is just the plain number that's out in front. So for example, the coefficient in this expression here, 3x squared, would be 3. The coefficient in this expression would be -4. The coefficient in this expression would be 1/3. And for this one, if there's no number in front of an x, we always assume it's a 1. So the coefficient in that term would be 1. So those are words that we'll be using as we go through. Now, the reason that we kind of build these different terms up is to try to sometimes group them even together into bigger chains. One of the most common ways that we work with terms is in a polynomial. A polynomial is essentially a term or a sum or difference of terms. So we can have one term, or we can add a bunch of them together, or we can add or subtract them together. Any of those things work. So terms separated by plus or minus signs are all okay. There is one additional restriction that we have when we're talking about polynomials, and that is that the exponents need to be counting number powers. So we can't have an exponent of -6. We can't have an exponent of 2/3. If we do, it will be a term, but it will not qualify in this special polynomial term. So polynomials always have nice powers when it comes to that. And then one other term that one other vocabulary word, I guess. We can be careful about using the word term. One other vocabulary word that I'll use a lot, especially in this section, is called a binomial. And a binomial is just a very specific type of polynomial. It's just a polynomial with exactly 2 terms. So something like x squared minus 3y would be an example of a binomial, where we have a term and a term that's being added or subtracted. So we have 2 terms. Or something like 3x minus 5 would be a binomial, because we have a term here and a term here that's being added or subtracted. So those give us kind of some specific pieces as we go in.